Welcome to this introductory video on the quantification of sleep and sleep disorder breathing with Sleep Profiler PSG2. In this first segment, the methods used to autostage sleep will be explained. From the frontal sensors, the differential recording from AF7 and AF8 is the primary signal used to stage sleep. The power spectral characteristics of the conventional EEG bands, plus the power from 32 to 128 Hz, which we refer to as EMG, is combined with the detection of spindles, cortical arousals, microarousals, and ocular activity measured from the left and right EOG channels to stage sleep. Each stage has a designated color. The signals used to stage sleep are presented in the upper third of the screen, and the signals used for detection of sleep disordered breathing are presented in the bottom third. The sleep disordered breathing events and staging are presented at the bottom. The upper hypnogram identifies the stages associated with the current screen presentation. The lower hypnogram presents the entire night, with blue markings to identify the location of the current screen with respect to the entire record. Sleep staging is based primarily on the interrelationship between the power spectral density characteristics. As snoring begins at sleep onset, a decrease in both beta and EMG power provides the most apparent change. Increases in delta and theta power increase only after the transition to slow wave sleep. Transitions between non-REM and REM are commonly distinguished by a marked decrease in sigma and alpha power and increase in beta power. In the top example, the EMG also decreases during REM. In the lower example, the power spectra is less intense. However, there is a marked change in beta power relative to the other frequency bands in the transitions between non-REM and REM. In addition to the power spectral characteristics, cortical arousals are used to define epochs to be staged in one. Cortical arousals require a minimum 3-second increase in alpha power compared to the median alpha across the previous 120 seconds. This cortical arousal is confirmed by autonomic activation, identified by a 6 beat per minute increase compared to the pulse rate from the previous or subsequent 10th second. Microarousals are also used to stage N1. Microarousals require a minimum 3-second increase in either alpha or EMG activity. In this example, the EMG is elevated primarily in the middle portion of the arousal. Sleep spindles are included in the staging of N2. Spindles require a spike in both the absolute and relative alpha and sigma power. Simultaneous suppression of beta and EMG power is used to avoid false detection of benzodiazepine-related pseudospindles. The amplitude of slow-wave sleep is attenuated at the frontal polar sites. The 30 microvolt dashed lines assist in the confirmation of delta activity similar to the conventionally measured 75 microvolts. Sharp ocular activity in combination with high beta and low EMG is required for the detection of phasic REM. To assist with interpretation, the EEG signal is presented after decontamination of ocular activity. The contiguous sequence or block of REM epochs requires at least one epoch of phasic REM to accompany any number of epochs with tonic REM. The autostaging rules always assign the first epoch after awake to stage N1 unless there is a sleep spindle. Epochs with gross EMG activity will be staged awake despite the potential for over half of the epoch having undisturbed sleep. Note the timing and magnitude of the EMG activity can be visually recognized in a 10-minute presentation of the power spectra to assist in identifying those epochs that should be more carefully inspected. The epoch in which a cortical arousal begins is assigned stage N1. This epoch is staged N2 because the cortical arousal began in the previous epoch. Epochs with any number of spindles and only one arousal will be staged N2. Epochs with two arousals and any number of spindles will be staged N1. Cortical arousals detected during slow wave sleep are included in the arousal index but do not result in the epoch being staged N1. Epochs are assigned light N2 or L2 when K complexes or consistently elevated alpha or EMG power is detected. The proportion of total N2 sleep classified with the light N2 characteristic is included in the tabular report. Epochs with beta bursts or beta spindles in proximity to phasic REM are classified as tonic REM. The proportion of total REM with phasic activity is included in the tabular report. Signal segments contaminated with artifact are colored red, and when the EEG signal is excessively contaminated, the left or right EOG signal may be used for staging. When artifact is extensive in all three channels, the epoch is staged invalid. The percentage of good signal quality for each channel is provided at the bottom of the graphical report. Next, we will review the rules used to detect sleep disorder breathing. 10-second cessations in airflow are marked in pink, and greater than 30% reductions in airflow are marked in blue. Visual confirmation of the auto-scored apneas and hypopnea patterns may be obscured by the pressure transducer's sensitivity to small breaths, not typically apparent unless the airflow signal is magnified. The SpO2 signal is marked with a dark gray stripe for a 4% desaturation and a light gray stripe for a 3% desaturation. For detection of hypopneas, the latency of the nadir of the desaturation must be within 9 to 60 seconds of the airflow nadir. Apnea and hypopnea events must overlap with at least some portion of a sleep epoch. Events that do not overlap with sleep are marked with an X. Once an overlapping stage is changed to sleep, the X will disappear and the event will be included in the apnea-hypopnea index. A 4% desaturation criteria is the default requirement for a hypopnea. When the desat criteria is changed to 3%, the additional hypopnea events will be automatically presented and the report will be adjusted when the record is saved. Respiratory event-related arousals, or RERAs, are detected when the start of a cortical arousal begins between the nadir and the point of peak recovery of an airflow event. When the desaturation setting is changed from 4% to 3%, a RERA that meets the alternative desat criteria will automatically be changed to a hypopnea. The study report identifies whether a 4% or a 3% desaturation criteria is applied to the computation of the apnea-hypopnea index. The respiratory disturbance index includes apneas, both 4% and 3% hypopneas, and RERAs. Note a change in the desat criteria affects the AHI and the RERA indexes, but not the RDI. Finally, periods with bad or missing oximetry or airflow are marked to highlight the need for visual inspection. In the final section of this video, we will review the most efficient means to edit the auto-scoring. A number of features are provided to speed up the editing process. The page down key will change the presentation to a 10-minute screen. The page up key will return a 30-second epoch that appears at the left edge of the 10-minute screen. Alternatively, you can double left-click at any point on the entire night hypnogram to open a 30-second screen. The left and right arrow on the keyboard, or the functions at the bottom of the screen, enable scrolling throughout the study. The signals are defaulted to a plus or minus 75 microvolts for the EOG and plus or minus 50 microvolts for the EEG signal with a 0.1 Hz high-pass filter applied. When more than 3 seconds in a 30-second epoch staged N2 or N3 exceeds the presentation range, the sweat or breathing artifact is removed with a bandstop filter applied to all 3 channels. This filter can be manually applied using the down arrow or removed using the up arrow. Alternatively, the filter and unfilter buttons at the bottom of the screen can be used. Impedance values presented at the top of the screen can assist in interpretation of signals contaminated with artifact and identify when the sensors are not properly affixed. The clock time and the elapsed time based on the left edge of the screen and the elapsed time associated with the location of the mouse are presented at the bottom of the screen to assist with navigation. When the left click and drag feature is used, the elapsed time or distance of the region is presented in the bottom of the screen. The sleep stage can be edited by multiple means, and in all cases a T with a red box will identify when the stage has been edited. The stage can be edited using the designated keypad entry. Once changed, the presentation will automatically advance to the next stage. Multiple epochs can be edited using the left click and drag feature. Alternatively, right-click on any stage stripe to edit a 30-second epoch. These same features are used to insert, reject, or change sleep disorder breathing events. We are now going to edit 3 studies, applying the techniques where the auto-staging is confirmed by review of the power of spectral density characteristics on a 10-minute screen with selective review of 30-second epochs. Our goal is to present this information fairly rapidly and to provide you the opportunity to review these same records at your convenience at www.sleepprofiler.com. Just click on the Guest Exploration icon. You will need to install the latest version of Java to review the signals, and any edits that you attempt to make will not be saved. The top 3 studies in Guest Exploration include the cardiorespiratory signals acquired with the PSG2. Always select the top study, as that is the most recent one processed. The study opens on a 30-second epoch. You can observe from the overnight hypnogram the transition to sleep onset, the completion of the first, the second, and the third sleep cycles. So the first thing I'm going to do is move into the area where sleep onset occurred by left-clicking. I'm going to hit page down and go to a 10-minute screen. So I'm using the left arrow key to go backwards. Here are a couple of periods where the patient was identified as being awake with the possibility of N1 here, here, and here. So in looking at the pattern of the power spectral characteristics, they begin to fall asleep, maybe, then arouse, and again arouse, and again arouse. So the likelihood of this actually being asleep is quite low. Transitioning through the record on a 10-minute screen, we see slow wave sleep, the blue stripes which are spindles, and you see the mixture of high relative amplitude sigma activity, which is the green, and that's an indication of deeper non-REM sleep. And it is approximating the plus or minus 30 microvolt, which means that the staging is working appropriately. Now we can see the transition to REM. You can see the sigma activity coming down, where the pink and the rust color are the primary or the most dominant signals. So what I'm going to do is just select an epoch anywhere in the REM block and look for phasic REM. It's there, so now I know that this entire block is good. And they begin to transition out of REM here. There are 2 epochs suggesting that the patient may have transitioned to sleep slightly earlier. So we'll go into the first epoch. There's a little bit of slow roller activity, and for purposes of demonstration, I'm going to say that this is N1 sleep. Because I'm on a 30-second screen, I can press the 1 on the keyboard. That will automatically convert this epoch to technically edited N1, and it moved me forward 1 epoch. I'm going to go back to the 10-minute screen and continue editing the study. We can see the increase in sigma and alpha activity, which is the green and the pink, indicating that they're in non-REM sleep. And I'm seeing a lot of events that have hypopnea activity and 3% desaturations. So I'm going to change the desat criteria to 3%, and now all of those hypopneas are going to be called. Continuing through the record, we encounter a RERA that is really generated by this movement and the artifact. So I put my cursor over the stripe, right-click, and reject the event. Again, the transition from non-REM to REM activity. I will go into this period and look for the phasic activity. So I'm going to exit out, hitting the page down screen. Notice that the airflow signal is getting smaller and smaller, so I will increase it by pressing the plus arrow. And finally, the airflow is bad. In this region, you would need to use the effort signal and the oximetry to insert events. If, for example, we decided there was an event here, I would left, drag and click, and insert hypopnea. After the patient moved, the airflow returns, and we see a transition from REM, kind of a mixed wake-sleep period. Now, the short duration of this REM suggests that it may be N1, so I'm going to go into the middle of this block and look for some phasic REM. And because I don't see it, I'm going to left-click, drag, release, and convert to N1, and continue editing the record. So you can see the patient now has transitioned where they're now going into deeper non-REM sleep with the return of the green sigma-like activity. There is movement here that caused this RERA or change in airflow to occur. Its artifact, I'm going to leave it rejected. And continuing through the record, we're transitioning into another REM period. Going to go in and look for a block, and there's the phasic REM. There's an awakening here. You can see the increase in EMG activity with the awakening. Transitioning back to REM, I'll check again to make sure. There it is. This is a long obstructive apnea that resulted from this movement, so it should be rejected. Looks like we're approaching the end of the night. You can see the blue box, and it looks like the patient has turned off the oximeter at this point. So what I'm going to do is insert into study, and that will cause all of these to be invalid, and we'll adjust the recording time to indicate that this is the end of the study. That finishes the first of the 3 studies we're going to edit together. So I'm going to save the changes. And again, when you use guest exploration, any changes or edits that you make will not be saved.
The next study we're going to edit is identified as severe OSA. First, I'm going to open the report, and I can see that because the clinical history is complete with the Epworth score, PHQ-9, Insomnia Severity Index, and the GAD-7, that this patient filled out the sleep profiler questionnaire, and it was entered prior to generation of the report. To conduct a technical review on the study opens on a 30-second screen, so I'll press page down to transition to a 10-minute screen, and with the right arrow begin transitioning through the record. The auto-scoring identifies sleep onset right at the point that the snoring begins. These 2 RERA events are not being called because these epochs are staged awake. They do not look like significant sleep disorder breathing, so I'm going to leave it as it is. Now I'm continuing in the record, and you can see that this patient is quite severe with repeated apneas. I can go quite quickly through the record in that they're clearly in non-REM sleep, and we're identifying all the events that we should. Here the patient appears to fall asleep briefly. I'm going to go in and inspect these 3 to see if these should be called sleep or not. And they look okay, so I'm going to leave those like they are. And we have a long awake period. You can see these periods marked in red. It's quite common for EMG to be marked in that red coloring. Proceeding through the record, there was some movement here to help explain why we see some changes in respiration. And because this event is being called N1, this RERA is being called. I do not see enough of a change in the effort channel to justify including this obstructive apnea event. And now you can see that the patient is transitioning back to sleep. It's unlikely that this early onset REM is correctly staged. but we'll go in and look for the phasic REM, and instead what we see are slow rollers. So I'll go back to a 10-minute screen and mark all of these as stage N1. And then hitting the right arrow, continuing to go through the record. Now this is another case where we see 3% desaturations that are not being called because the default was 4%. So I'm going to change the desat criteria to 3%, and now more of the hypopneas will appear. I'm transitioning through the record. Again, non-REM sleep is being properly scored, and you can see we're transitioning from non-REM to REM. I'm going to go in and look for the phasic REM to confirm. There it is. I'm going to exit out, and we're at the end of the study. You now have the opportunity to insert some standard messages into the narrative report, or to insert your own custom comments that will appear above your signature. When you've completed these edits, press Save, and we're now finished editing the study. If this editing was performed by a technician and you wish to notify the clinician it's time for interpretation, change the status to interpretation required, and an email will automatically be sent notifying the clinician that the study is ready for interpretation. For this final study, I'm going to proceed through the editing quite quickly. I'm going to go to page down and start transitioning through the record. There's a couple of epochs of N1 sleep. I will check these, and I think the patient is asleep there. And I'm going to leave these events like they are. You can see the slow wave sleep is being called, and there's clear delta activity here where they awaken briefly, and I have a mixture of N3 and REM sleep. So I'm going to go in and look at this, and I'm going to use the filter so that I use the down arrow, and that filters the signal and helps me realize that the large delta power here is what is causing this to be misclassified as REM. So I'm going to change it to N3 and continue on with the editing. At this point we lose the oximeter temporarily, so I'm going to reject this entire period to tech invalid. This hypopnea will not be called unless I convert this to N1. And now we see a couple of REM events that look a bit out of place. So we're going to go in and look for the phasic REM. Clearly that's not the case, so I will hit 1 and 1. There's a awakening here, and they're transitioning back to sleep here. I'll leave that awake. N1. This REM event is incorrectly called. This should be stage N1, and that should as well. And then they awaken again here. So I'm going to go back to a 10-minute screen. And here, this event I need to convert to N1 in order for it to be counted. Again, I have a couple of stray REM events that should be N1. I'm going to convert this to N1 and this secondary event to N2. So now at the end of the study, if I save as final, it gives me a message that says we can only save one file as the final report. If I click on yes, it will provide the opportunity to insert my signature into the report, and that concludes the editing of these 3 studies. Feel free to use guest exploration in combination with this video to evaluate the accuracy and efficiency of the quantification of sleep and sleep disorder breathing with Sleep Profiler PSG2.